Bismillahirrahmanirrahim. Question number 1. Find the common difference and write the next two terms of each arithmetic sequence. In this arithmetic progression, first term is 9 and the common difference, that is difference between two consecutive terms, we can find it as 16 minus 9, that equals to 7. By applying the formula of finding nth term, we can write a1 plus n minus 1 into d, and we have three terms already, a1, a2, a3, and we have to find the next two terms, that means a4 and a5. So by applying the formula and putting the value of n equals to 4 in this, we get a1 plus 3d and a4 equals to 9 plus 3 into 7, that becomes 30. A4 is 30 and A5 equals to A1 plus 4D. 9 plus 4 into 7, 9 plus 28, that becomes 37. A5 equals to 37. This is our required two terms, and in second part, arithmetic sequence is 5, 5 plus 2 under root, 5 plus 2 into 2 under root. Here a1 equals to 5 and d is 5 plus 2 under root minus 5, that equals to 2 under root. Now we have to find a4 and a5 by applying this formula. A1 is 5 plus 3 into 2 under root. This is our a4. Next, a5 equals to a1 plus 4d, 5 plus 4 into 2 under root. This is our required result. Next question. Write the first three terms of each arithmetic sequence with given information. And in first part, a1 equals to 3. Our d is equal to 13. We can find by applying the formula a2, a3 and a4. And a2 equals to a1 plus 1d, 3 plus 13. So a2 equals to 16 and a3 equals to a1 plus 2d, 3 plus 2 into 13, 3 plus 26, that equals to 29. And a1 is 3, a2 is 16, a3 is 29. This is our required result. And in second part, A1 is 12, D is minus 13. So A2 equals to A1 plus D, means 12 plus minus 13. A2 equals to 12 minus 13. A2 equals to minus 1. And A3 equals to A1 plus 2D. 12 plus 2 into minus 13. 12 minus 26 minus 14. A3 equals to minus 14. In question number 3, find an plus 1 and 2n if an is equal to 4 plus 3n. We can find an plus 1, that should be equals to 4 plus 3 into n plus 1. An plus 1 equals to 4 plus 3n plus 3, and an plus 1 equals to 7 plus 3n. And for finding the value of a2n, we have to put 2n in place of n. We get a2n equals to 4 plus 6n. This is our required result. In question number 4, find the indicator term of each of the following arithmetic sequence. Here a1 equals to 3, d equals to 7, and indicator term is a14. So a14 equals to a1 plus 13d, and a1 is 3 plus 13 into 7, 3 plus 91. A14 is 94. In second part, indicator term is A12. Here A1 is 8 and D is 3 minus 8. D is equal to minus 5. So A12 equals to A1 plus 11D, and A1 is 8. 11 into D is minus 5. 8 minus 55 means minus 47. Next, question number 5. The 18th term of a sequence is 367. 18th term is 367 and 30th term is 499. By applying the formula a1 plus 17d equals to a18, that is 367, and a1 plus 29d equals to 499, 1, and this is 2, By subtracting these two terms, we get plus 29D equals to 499 367. This equals to 12D equals to 132 and D equals to 132 over 12 and D equals to 11. By putting this value of D, putting in equation 1, we get A1 plus 17 into 11 equals to 367. A1 plus 187 equals to 367. A1 equals to 367 minus 187. A1 equals to 180 and An equals to A1 plus n minus 1 into D, and An equals to 180 plus n minus 1 into 11. An equals to 180 plus 11n minus 11. An equals to 169 plus 11n. What is this An? How many terms of this sequence are less than 1000? So we have to put the nth term that is less than 1000, means An should be less than 1000. So our above equation become 11n should be less than 1000, and if this is true, then 1000 minus 169 into n should be less than 831 over 11, and n should be less than 75.5, means our number of terms less than 1000 are 75. In question number 6, is 301 a term of arithmetic progression of 5, 11, 17? Means n equals to 31, a1 equals to 5, d equals to 11 minus 5 equals to 6, and an we have to find the n. An equals to a1 plus n minus 1 into d. An is 301, a1 is 5 plus n minus 1 into 6. 305 equals to 5 plus 6n minus 6. 301 minus 1 plus 6n and 301 plus 1 equals to 6n. 6n equals to 302. That means n equals to 302 divided by 6, which is uh, not a natural number, not a natural number. So 301 is not the term of given arithmetic progression. If this is the term of given arithmetic progression, there will be a answer of n is the natural number. So we can say that this is not the term of. If 2x, x plus 8, 3x plus 1 are in arithmetic progression, find the value of x. This is the condition for terms in arithmetic progression. Their common difference will be same. Mean x plus 8 and 2x difference should be equals to 3x plus 1 minus x plus 8 by expanding 3x plus 1 minus x minus 8 minus x plus 8 equals to 2x minus 7, and this minus becomes plus 7, and this minus becomes plus here. 15 equals to 3x, x equals to 5. So value of x will be 5 for arithmetic progression. Which term of arithmetic progression 3, 8, 13 is 123? Mean our an is 123 and we have to find n. How we can find? By applying the our basic formula. An equals to a1 plus n minus 1 into d, and our a1 is 3 and d is 8 minus 3 and d is equal to 5. So applying an equals to 3 plus n minus 1 into 5, and an is 123. 3 plus 5n minus 5, and 123 equals to minus 2 plus 5n, and 123 plus 2 equals to 5n. 5n equals to 125, n equals to 125 divided by 5, n equals to 25. So 123 is 25th term. Which term of arithmetic progression 30, 29.5, 29, 28.5 is the first negative term? Here we have to find the an, and a1 is 30 and d equals to 29.5 minus 30 equals to minus 0.5, and an equals to a1 plus n minus 1 into d. An equals to 30 plus n minus 1 into minus 0.5, and an equals to 30 plus minus 0.5 n plus 0.5 mean an equals to 30.5 minus 0.5 n. According to the condition of our question, our an is first negative term, mean less than 0. So put an less than 0, we get 30.5 minus 0.5 n less than 0, and 30.5 should be less than 0.5 n, and 30.5 over 0.5, and n should be greater than 61. Mean if n equals to 65, that term will be negative. 30.5 minus 0.5 into 62, an equals to minus 0.5. It means our n should be less than greater than 61. A to be first negative, यानी 62 में जो होगी ना वो नेगेटिव होगी, 62 में होगी. In question number 7th and the 21st question is 7 and 7. Find the arithmetic progression, it's 100. Here a7 is given, that is 37, and a 21st term is 107. We can write it as a1 plus 60 equals to 37, and a21 equals to a1 plus 20d equals to 107. This is our first equation, this is our second equation. By subtracting 1 from 2, we get a1 plus 20d equals to 107 minus a1 plus 60 equals to these will be cancelled. 14d equals to 70, d equals to 70 by 14 equals to 5. So a1 equals to, by putting the value of d in equation number 1, we get 37 minus 60. a1 will be 37 minus 6 into 5. a1 equals to 7, and a2 will be equals to a1 plus d, that is 7 plus 5 equals to 12. a3 equals to a1 plus 2d, 7 plus 2 into 5 equals to 17. Our arithmetic progression is 7, 12, 17, 20, so and so on, and a equals to 90, that equal to 7 plus 29 to 5, that equals to 7 plus 5 to 200. method is 502. 1 over a minus c, 1 over b minus c, 1 over b minus a are in arithmetic progression, then show that a minus b over a minus c should be equal to a minus c over b minus a. So we know that if any term is in arithmetic progression, if 1 over a minus c, 1 over b minus c, 1 over b minus a are in arithmetic progression, then their d will be equal, mean 1 over b minus c minus 1 over a minus c should be equals to 1 over b minus a minus 1 over b minus c. By taking the LCM, b minus c into a minus c, a minus c minus b minus c equals to b minus a into b minus c, b minus c minus b minus a. This b minus c will be balanced by this b minus c. By expanding the upper brackets, we get b minus c minus b plus a over a minus c over b minus a, and this c will be balanced by this b will be balanced by this a minus b over a minus c equals to a minus c over b minus a. This is our result that we have to prove, hence proved. How many number of 3 digits are divisible by 7? First of all, we have to see that divisible 3 digit numbers are actually starting from 100 to 999, and those are divisible by 7 are 105, 112, 19, and so on 994, means 3 digit numbers are 100, 101, 103, so and so on 999, but numbers divisible by 7 are 105, 112, so and so on 994, because all 3 digit numbers are not divisible by 7. So our A1 from this arithmetic progression is A105 and AN is 994, and our D is, as it is preset, 7. So AN equals to A1 plus N minus 1 into D, and N is 994, A1 is 15 plus N minus 1 into D is 7, and 994 equals to 105 plus 7N minus 7. 94 equals to this 98 plus 6 6 and 18 796 equals to 7n 7n equals to 790 896 896 n equals to 896 by 7 n equals to 128. So 128 3 digit numbers are divisible by 7. 3 digits starting from 105 ending at 94 are 128. Find the eighth term of end of the arithmetic progression. We can solve this question by reversing the order of our arithmetic progression. 185, 182, 179, so and so on. 14, 11, 8. As by reversing, A1 becomes 185 and D equals to 182 minus 185, that means minus 3, and now we have to find nth term, mean 8th term, and this is our first term, second, third, so and so on, 8th term, and A8 can be written as A1 plus n minus 1 into D. So A8 A1 plus 7D, and A1 is 185 plus 7 into minus 3, and 185 minus 21 means 164. 8th term at from the end is 164. Find the nth term of progression. 3 by 7 raised to power 10, 10 by 7 raised to power 10, 17 by 7 raised to power 10. Is this progression is arithmetic progression? First of all, we consider 3, 10, 17 is arithmetic progression. So A1 equals to 3 and D equals to 10 minus 3 equals to 7, and nth term can be write is 1 plus n minus 1 into D, and an equals to 3 plus n minus 1 into 7, an equals to 3 plus 7n minus 7, an equals to 7n minus 4. So nth term is as 7n minus 4 over 7 raised to power 10, as there are power raised to 10th. making this progression nonlinear. So it is not an arithmetic progression. If the arithmetic progression 3, 10, 17 and 63, 65, 67 are such that their nth term are equal, find the value of n. If 3, 10, 17 is an arithmetic progression, a1 is 3 and d equals to 10 minus 3 equals to 7, and a1 for this arithmetic progression is a1 plus n minus 1 into d, and an equals to 3 plus n minus 1 into 7, an equals to 3 plus 7n minus 7, n equals to 7n minus 4. And the second arithmetic progression 63, 65, 67, a prime n for this is a1 plus n minus 1 into d, and here a1 is 63 and d is 2, so a prime n equals to 63 plus n minus 1 into 2, a prime n equals to 63 plus 2n minus 2 means 61 plus 2n. According to the statement, a n and a prime n equals to, so 7n minus 4 equals to 61 plus 2n, and 7n minus 2n equals to 61 plus 4, and 5n equals to 65, n equals to 65 over 5, and n equals to 13. For n equals to 13, that is true. Question number 16. If the pth term of arithmetic progression is q and qth term of arithmetic progression is p, prove that its nth term is p plus q minus n. If pth term is q, then by formula we can write as an equals to a1 plus n minus 1 into d. Here we are discussing the pth term equals to a1 plus p minus 1 into d. This is q a1 plus p minus 1 into d. This is our equation number 1, and qth term a qth term of arithmetic progression a plus a1 plus q minus 1 into d, and a qth is p a1 plus q minus 1 into d. This is equation number 2. Now subtracting 1 and 2, we get q equals to a1 plus p minus 1 into d, and minus p equals to minus a1 plus q minus 1 into d. These two will be cancelled, and q minus p equals to p minus 1 into d minus q minus 1 into d. Q minus p equals to pd minus d minus qd plus d. Here q minus p equals to pd minus qd, and q minus p equals to p minus q into d, and d will be equals to q minus p over p minus q. That means minus p minus q over p minus q. These two will be cancelled, and our d will be equals to minus 1. Put this value in equation number 1. We get q equals to a1 plus p minus 1 into minus 1, and q becomes a minus p plus 1, and q equals to a1 minus p plus 1. This will become q plus p minus 1. This is our a1. Now we can find the an equals to a1 plus n minus 1 into d. An equals to, putting the value of a1 here, q plus p minus 1 plus n minus 1 into minus 1 a n equals to q plus b minus 1 plus this plus minus becomes a minus n, and this minus becomes the plus a n equals to q plus b minus n or p plus q minus n. If 1 over a, 1 over b, 1 over c are in arithmetic progression, then show that b equals to 2ac over a plus c. For this, that if 1 over a, 1 over b or 1 over c are in arithmetic progression, then their common difference is 1 over b minus 1 over a will be equals to 1 over c minus 1 over b. 1 over b and this minus 1 over b will become plus 1 over b when shifted towards the left hand side, and this will also become the positive. And now by taking LCM, we see that a plus c 2 over b equals to a plus c over ac, and by cross multiplication we get 2ac equals to b into a plus c, or b into a plus c equals to 2ac, and b equals to 2ac over a plus c. This is required result, hence proved. In next question, he is saying that if 1 over a or 1 over b, 1 over c are in arithmetic progression, then show that d is equal to 1 minus c or a minus c over 2ac. Similarly, as in previous question we have solved for b is equal to 2ac over a plus c, we have to calculate up to this b is equal to 2ac over a plus c in this same manner. Then we have to calculate the d, as we know that d equals to 1 over b minus 1 over a, and d equals to 1 over b minus 1 over a. Put the value of this b in this equation, we get 2ac over a plus c minus 1 over a, and we can write it as a plus c over 2ac minus 1 over a. Now by taking the LCM of this 2ac as divided by this 2ac by 2ac, answer will be 1, and 1 is multiplied with a plus c, minus a divided by with 2ac, answer will be 2c. By expanding this, a plus c minus 2c over 2ac and this will be A minus C over 2AC. This is the required result which we have to prove that D equals to A minus C over 2AC. If AK and AM denotes different terms of arithmetic progression, show that its nth term is AK plus n minus k into AK minus AM over k minus m. So now we have to solve this AK and AM. Those are in arithmetic progression. Then we can write A equals to A1 plus k minus 1 into D. This will be our first equation, and AM equals to A1 plus m minus 1 into D. This is the second equation. Now subtracting these two equations, we get AK minus AM equals to, this A1 will cancel with the second A1, and k minus 1 D minus m minus 1 into D. In next step we will expand these KD minus D minus MD plus D. This minus D will cancel this plus D, and AK minus AM equals to KD minus MD. By taking common in this D, our D becomes AK minus AM over K minus M. Now put the value of D in equation number 1. We get AK. This equation number 1 becomes A1 plus K minus 1 into AK minus AM over K minus M, and by rearranging this, A1 can be written in this form: AK minus K minus 1 into AK minus AM over K minus M. Now we want to write the nth term of this arithmetic progression by our famous formula A1 plus n minus 1 into D. Put the value of A1 from here and D from here in this formula. We get AN equals to AK minus K minus 1 into AK minus AM over K minus M plus N minus 1 into ak minus am over k minus m. Now by rearranging this we get an equals to ak if this minus multiplied with this term इधर प्लस आ जाएगा और ये जो माइनस के प्लस वन बन जाएगा। अंदर रह गया ए के माइनस ए एम और डिवाइडेड बाय के माइनस एम प्लस एन माइनस वन इंटू ए के माइनस ए एम डिवाइडेड बाय के माइनस एम and an equals to a k प्लस इन दोनों में से अगर हम गौर से देखें तो a k माइनस ए एम कॉमन है, a k माइनस ए एम और अंदर हमारे पास रह जाएगा माइनस के प्लस वन प्लस एन माइनस वन divided by k minus m and this ak plus ak minus am into this plus cancel with this and this becomes n minus k over k minus m. In next step by rearranging we will get our form n minus k into k minus am divided by k minus m. This is our required result. Hence prove that if a1 a2 a3 are in positive and in arithmetic progression, prove that 1 over a1 under root plus a2 under root plus 1 over a2 under root plus a3 under root so and so on 1 over an minus 1 under root plus an equals to n minus 1 over a1 and plus a n under root. For proving this we have a1 a2 a3 so and so on an, those are positive and in arithmetic progression. So if these are in arithmetic progression we can write, so we can write common difference d equals to a2 minus a1 and an equals to a1 plus n minus 1 into d, and from here we can find the d equals to an minus a1 over n minus 1. This is 1d, this is second. By using these we have to prove as let LHS, that is 1 over a1 under root in plus a2 under root plus 1 over a2 under root plus a3 under root plus so and so on 1 over an minus 1 under root plus an under root. By rationalizing this, by multiplying a1 under root minus a2 under root over a1 under root minus a2 under root multiplied by a2 under root minus a3 under root into a2 under root minus a3 under root, and this an minus 1 under root minus an divided by an minus 1 minus an. Now ये ऊपर 1 से मल्टीप्लाई होके आ जाएगा आपके पास a1 अंडर रूट माइनस a2 अंडर रूट, और नीचे आपको एक फार्मूला पता है a प्लस बी इंटू ए माइनस बी, ये किसके बराबर होता है ए स्क्वायर माइनस बी स्क्वायर। a1 अंडर रूट माइनस ए अंडर रूट डिवाइडेड बाय a plus b into a minus b, and this becomes a1 under root square minus a2 under root square plus a2 under root minus a3 under root divided by a2 under root square minus a3 under root square plus so and so on an minus 1 under root minus an divided by an minus 1 under root square minus an under root square. This becomes a1 under root minus a2 under root divided by a1 minus a2 plus a2 under root minus a3 under root divided by a2 minus a3 plus so and so on an minus 1 under root minus an under root divided by an minus 1 minus an. By multiplying minus 1 a1 under root minus a2 under root divided by minus a1 minus a2 plus minus a2 under root. This minus becomes a2 under root minus a under root or 2 minus a1 plus a3 minus a2 a minus a2 plus a under root minus an minus 1 under root divided by this minus multiplied by this becomes a minus n minus, and this is the plus an, so we write it first. Now putting the value of this D. This is D. A2 minus A1 and A3 minus A2 so D. So for D R places A2 minus A1 plus A under root minus A2 root D plus 1 A n root minus A minus 1 D. Taking m of 4 this D. This comes A2 root minus A1 under plus A3 root minus A2 under root plus A4 under root minus A3 root so and so on. A minus 2 under an plus 1 under root minus an is 2 under root plus 1 under root minus an minus 1 under root. This A4 under root will cut this 3 with A4 minus A4 this A minus this and this A minus with the we have only हमारे पास सिर्फ और बचेगा an under root minus 1 under root. तो इसको रीअरेंज हम लोग स्टेप में रख सकते हैं n minus root minus 1 under root over d. Now we have the value of d by our formula this an minus a1 over minus 1. So put value of d here. We get an minus a1 over n minus 1 and this becomes n minus 1 into an under root minus a1 under root over an minus a1 and we can write it as n minus 1 into an under root minus a1 over an under root square minus a1 under root square. By cancelling square with under root will also becomes an minus 1. ये इसलिए लिखा है ताकि ऊपर वाला नीचे वाले के साथ कैंसिल हो सके और आपको पता है कि ए स्क्वायर माइनस बी स्क्वायर किसके बराबर होता है ए प्लस बी इंटू ए माइनस बी. तो अब इसकी जगह पे हमने लिखना है n माइनस 1 इंटू ए एन अंडर रूट माइनस a1 अंडर रूट ओवर ए एन अंडर रूट प्लस a1 अंडर रूट इंटू ए एन अंडर रूट माइनस a1 अंडर रूट इंटू ये कट गया और आपके पास बच गया वो क्या है वो है n माइनस 1 इंटू ओवर ए एन अंडर रूट प्लस a1 अंडर रूट. दिस इज आवर RHS. If the roots of equation b minus c x square plus c minus a x plus a minus b equals to 0 are equal, show that a, b, c are in arithmetic progression. Its solution is this. We have to show a, b, c are in arithmetic progression. So their common difference b minus a equals to c minus b. In this question, the given b minus c x square plus c minus a into x plus a minus b equals to 0, as this is quadratic equation of this form, and we know that b square minus 4ac equals to 0. So b is this. We take let a equals to b minus c, b equals to c minus a, c equals to a minus b. Put the value of b, c minus a square minus 4 into b minus c into a minus b equals to 0. Expanding this square, c square minus 2ca plus a square minus 4 into this ba minus b square minus ab ac plus bc equals to 0. C square minus 2ca plus ac a square minus 4ba plus 4b square plus 4ac minus 4bc equals to 0. This c square minus plus 2ac plus a square minus 4ba plus 4b square minus 4bc equals to 0. By rearranging a square plus 4b square plus c square minus 4ab minus 4bc plus 2ac equals to 0, as this is plus c square minus 2ga plus 2 into minus 2b into c plus 2a equals to 0. This is the complete square of a minus 2b plus c equals to 0. Taking square root on both sides, we get a minus 2b plus c equals to 0. Square root 2b plus c 0. A plus c equals to 2b. A plus c is equal to b plus b. This b minus a, b minus a can be equal to C minus B, which shows that B or C are in arithmetic progression. Question 22. If the sides of the right angle triangle are in arithmetic progression, find the ratio of its sides. Let one side is A, second is A minus D, third is A plus D. Let's one side is A minus D and second is A and third is A plus D, which is hypotenuse, and A plus D has hypotenuse square equals to base square plus perpendicular square by Pythagoras theorem. So A plus D square can be written in this way: A minus D square plus A square. By opening it, A square plus 2AD plus D square equals to A square minus 2AD plus D square plus A square plus 2AD plus D square, and this A is, can be cancelled with this A by taking toward this side plus 2AD minus D square minus A square equals to 0. This A square is cancelled with this A square, this D square with this A square minus A square plus 4AD equals to 0. Can be written in this way: minus 4AD equals to 0. A is common here. If A is common, then it should be A is equal to 0, or A minus 4D should be equals to 0. But A cannot be equals to 0 because length of any triangle can never be 0. So A minus 4D equals to 0 means A is equal to 4D, and if A minus D equals to 4D minus D is third D, 3D, first side is 3D, second side is 4D, and the third side is A plus D, means 4D plus D is equal to 5D. So the ratio of three sides of right angle triangle is 3D ratio 4D ratio 5D. It can be right in this way: 3 ratio 5, 5, and 5 square is equal to 3 square plus 4 square. Hence proved. Next question is If the nth term of the progression is a linear expression in n, then prove this progression is arithmetic progression. Its solution: linear term n is equal to pn plus q for n equals to 1, 2, 3, so and so on. So a1 equals to p1 plus q, a2 equals to 2p plus q, a3 equals to 3p plus q, and this is the arithmetic progression. And if this is our arithmetic progression, it should follow the common difference. For arithmetic progression, there will be common difference. तो उधर आपके पास जो कॉमन डिफरेंस आएगा दो कंसेक्टिव टर्म्स का माइनस p plus q equals to 3. Expanding these, this q will be cancelled and p should be equals to p. So from here we can see that it is an arithmetic progression.